Hello, welcome back. Today let's try to solve another Leetcode problem, 1267, called servers that communicate. So basically we are giving a map of a server center represent m times n, so it means m rows and n columns. So the condition is that we're gonna return the number of servers that communicate. So what is the condition for the communicate of any server? It means any two servers, if they are in the same column or in the same row, that means the two servers can communicate. For example, this one, there's only one server. It means this one cannot be communicated with this one. And for this example, so in the column 1, there are two servers. So it means these two servers can be communicated. And also for the first column or for the second row, there are two servers. That means these two servers can communicate. So in total, there are three servers, and in this example, there are four servers. So for such problem, we cannot use DFS or BFS directly. So if the servers must be connected to it, must be connected one step to it, we can use DFS or BFS directly. But for this problem, it is just for checking rows, how many servers in the same row or how many servers in the same column. So for this problem, basically we can use two paths. We're gonna prepare a set or an array for the row set or column set. For the first pass, we're gonna pass through each of the servers to put it inside the row array or the column array. That is just to calculate how many servers in each row or how many servers in each column. After that, we're gonna use the second pass. We're gonna check one by one. For example, if we go to this server, so how many servers in this row and this column? So if there are more than or equal than 2, it means we're gonna count by 1. And when it goes to this one, how many servers in this column? There are 2. How many servers in this row? There are 1. But in total, it is more than or equal than 2. It means we're gonna count this one. So we're gonna count by 4. Yeah, so this is the idea for solving such problem. For this kind of problem, I will call it two-pass matrix problem. Basically, we're gonna prepare some column array or row array or column set or row set to represent how many servers in each row or in each column. For the second pass, I'm gonna check one by one. So basically, this is a OM times n, OM times n time complexity, and also for the space complexity, if I use row and column, it is basically ON. Yeah, if m equals to n. Now let's check m and equal to n, 250. So it means we can pass, for this time complexity, because it is basically OMN for the time and space for the time complexity, and for the space complexity, it is just m times n. Yeah, now let's just start the coding. So as I said, I'm going to use the two-pass matrix method to solve the problem. So for the R, it will be length of the grid, and for the column, it will be length of the grid 0. And now I'm going to prepare a rows and columns array, or you can prepare a rows or column set. It's the same. Now we are going to prepare the row array. It will be 0 times R, and the column array, it will be 0 times C. So for the row array and columns array means, so for example, the rows array means how many servers inside each row. So the index means each row. So similarly for the column, the index means how many servers in each column. So it will be start from index 0 to C minus 1. So for the row, it will start from index 0 to R minus 1. Now let's just use the first pass. So it will be for R in range R, and for C in range C. Now we are going to check if this grid RC equals to 1. Here I'm not going to make it equal because it's the same. If grid RC equals to 1, it means because there are only 1 and 0 inside the grid, so we can use Yeah, it means if grid RC equals to 1, what are we gonna do? We just put it inside rows and columns. So the rows R should plus equal to 1, and columns C, we put it inside the column plus equal to 1. Yeah, so this means our rows and columns array has already been prepared. So for the next pass, we are going to check if it meets the conditions or not. So for the result, it's going to start from 0, and finally I'm going to return a result. Similarly, I'm going to use the second pass. So for the second pass, for R in range R and for C in range capital C, we're just going to check if this grid RC equal to 1. Yeah, so if it equals to 1, I'm not going to do it because this is just for checking grid RC equal to 1. And I'm going to check for the rows and columns. If rows, this R plus C, columns plus C, this one means how many servers inside this row and column. For example, my server is here. So how many servers in total? So inside each row, there's only 1. So inside this column, there are 2. So 1 plus 2, it is 3. But actually, it is 2. But for our checking, if it is more than 2, it means this one already meets the condition. It is connected at least 1. Why? Because if there's no server for this row and this column, it is at least 2 because this is 2. If it is more than 2, it means it will have at least 2 servers. Yeah, this is just some simple math calculation. So if this is only 1 server in this row and in this column, there are 2. Yeah, if there are 2 servers, for example here, it will be 3. So in the column, it will be 2. In the row, it will be 1. So if it is more than 2, it means it will have at least 2 servers connected. Now, we just need to update the result plus 1. So actually, this is the entire code. As you can see it is a difficult problem according to the description. But after analyzing of the problem, if we turn this problem into a two-pass matrix problem, we prepare some rows and columns. You can see it is so easy because it is also similar to the Shikudu server problem. You need also to prepare rows and columns set. And here's array and set, it's the same. Yeah, there's a lot of similar problem like this. Now let me run it to check if it really works. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. As you can see, it's pretty fast, nearly 100%. Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problems like this. See you next time.